Okay, welcome to ENVR Assignment 3. Today we're going to be working with the iris dataset, and this is an example dataset that's available from R. So you can see that we have these 4 variables for sepal and petal length and width for these 2 species, Setosa and Virginica. What we're going to be doing today is transforming this dataset so that we can widen this long version of the species so that we have each of them with their own columns, and we're going to be selecting different variables so that we can perform t-tests on them. Now, the first thing that we need to do before we do anything else is to save this file as a workbook. So right now, this is a CSV file, which you can see up here. And so that stands for comma separated values. And if you have a CSV file, it will only save one sheet, and it will only save the very basic stuff that's in the cells. So that's good for transferring files from other programs like R, but it's not so good when we're going to be doing manipulations in Excel itself. So we go and we click F12 or go to Save As from File, and we pick Excel Workbook. And then we hit Save. Now it's saved as a workbook, which means that we'll be able to keep any of the changes that we do. First thing that we're going to want to do is modify this as a table. So we use Control L and we transfer this into a table. We can change this name to iris, which is the data set that it is. Then we can right click and go to Get Data from Table Arrange and bring it into Power Query. Once it's in Power Query, you can see that we have all these different options. And the first thing that we're going to do is just pick one of these columns. So what we're going to do is go to Choose Columns, and we unclick the ones that we don't want, and we'll just keep sepal length as an example. And we also want to keep species because that's how we want to group them. We click OK. Now it would be great if we could just pivot wider from here. But the problem is that if you go to pivot this column and you say I want sepal length, and even if you tell it you don't want it to aggregate, what it does is it produces an error. So what we have to do is, instead of pivoting right from here, we have to add an index column that creates numbers that are the same for each species. So we want 1 to 50 for Setosa and then 1 to 50 for Virginica. And the way that we do that is we group by, and we go to species. We're going to create a new column that we're going to call all, and we say that we want all of the rows. Then we click OK. And now you'll see that this has this column for species, and it's grouped all of those rows of sepal length into this table. So we can click that table to visualize it, and you see that it's just the Setosa data. We don't need to actually keep that. What we can do now is we can add a column up here. We'll add this custom column, and we'll call this one our index. And so we go to table. We use the function table.add index column. And in this, it says, okay, what do you want to add the index column based on? And what we want to add it based on is all. And we have to make sure that we specify that with these square brackets. Alternatively, in Power Query, you can just double click all and it will add it in there, knowing that that's the column that you want to reference. We say comma, and the next thing is the new column name. So we make sure that it's in brackets, and we say index by species. We add a quote there. We add a column. It says, what is your initial value as a nullable number? Our initial value is going to be 1 because we want the numbering to start at 1. We add another column, and it says, or another comma, and it says, what do you want your increment to be as a nullable number? And then we say we want it to go up by 1. And so what that'll do now is it'll add a new index column based on the sepal length values that we have. It'll call it index by species. It'll start at 1, and it'll go up by 1 until it gets to the total number of observations, which happens to be 50 in this case. We click OK. And now you can see that we have this table. And if we click on one of those, you can see that it is Setosa with all of the sepal length and then the numbers 1 to 50. Now we don't need that, so we can just exit out. What we do want to do is expand this one to get both of these tables. So we click this weird little expand button up there. We say it has this tick box for use original column name as prefix. We don't need that, so we untick that and we press OK. Now you can see that we have setosa and virginica numbered 1 to 50 for all of our values of sepal length. At this point, we don't need these ones, so we can get rid of these old columns. So I click that one, and then I hold Shift, and I click that one, and we press Delete to get rid of both of those. Now we have this table, and now we can actually use our pivot wider. So we go to Pivot Column, and we say we want the values to be sepal length because we don't want it to be the index. We go to Advanced, and it says what function do you want to use, and that's because when you pivot it thinks that you want to group some values together, but we don't want to aggregate those groups, so we click that one and then we click OK. Now we have side by side setosa and virginica with all of the values of sepal length. So in the properties here we're going to call this sepal length with a space, not a period, because you can't have a period in that name for some reason. And that'll help us keep track of which one of these that we're doing, because we're going to do it for all of the variables. So now we click Close and Load. And you can see that it pops up named sepal length. We have our index, and we have our 2 species that are there. So now what we want to do is start to analyze sepal length. And what we're going to do is a t-test to test the null hypothesis that these are the same mean. So first of all, let's figure out how we can actually look at the mean. Now we could just use our average function, but instead of doing that a couple of times, let's get all of these descriptive statistics at once. So what we can do is we can go to our data tab and we can go to this data analysis button. If you don't have this data analysis button, what you need to do is go to File, go to Options at the bottom, and then you go to Add-ins. From Add-ins, you make sure that you're on Manage Excel Add-ins, and you go to Go, and then you make sure that this box for Analysis Toolpack is clicked. If you click it and then you click OK, and this still doesn't pop up, try exiting out of Excel and then trying that again. You might have to do it once or twice. We've had a couple of students that had that issue. But once you do have this button, you can get all of these different options for doing different types of analysis in Excel, and it can be very helpful. So the first one that we're going to use is descriptive statistics. We highlight that and we click OK. It asks, what is your input range? And so we highlight all of this, which I'm just holding the mouse there, and then I can do Control-Shift down to highlight the whole thing. I have labels in the first row, which are our column names there. It says, what do you want to group by? And we want to group by columns because our columns are our different groups. We have output range, and it says, where do you want me to put this new information? And I'm going to pick cell E1. And it has all these options for stuff, and we're just going to pick summary statistics there. So now you can see that we have summaries for setosa and for virginica, and you can see that our means are different by 1.5, and this sepal length is measured in millimeters, so they're 1.5 millimeters different in the mean. But is that a significant difference is really what we want to ask. So what we have to do in order to do that, first of all, is we can just look at it. So let's highlight all of this again, dragging across, Control-Shift down, and let's make a box plot. So we go to this Insert Statistics chart, and we go to Box and Whisker. So based on this, let's try and make this a little bit more clear so we could say insert it into a report. Excel kind of sucks because it doesn't allow you to use the x-axis to actually name your box plots for some reason. So we can delete that one, but we can get rid of our chart title, and instead of having the chart title there, we'll add a legend. And so the legend is based on the names that we already added into it. Let's get our axis titles in there for sure, and then we'll add species, and we'll add sepal length with our unit of millimeters. So now we can start to think about this a little bit more. So it seems that Setosa is a lower mean than Virginica, and that it has a little bit less of spread than the Virginica as well. So it looks like there's a difference here, but what we're doing is we're going to use statistics to support the hypothesis that there is a difference here. And so in order to do that, what we have to do first is check the assumptions of the t-test. And the first thing that we're going to do is the assumption of normality. And so what we can do is to check the distribution of the data, we highlight all the values in Setosa, go to insert, and we make a histogram for it. Let's just, because we're going to do this for both species, let's make sure that we name this one Setosa. And what this is showing us is the number of observations of values that are between these different numbers. And so you can see that in the middle, near 5, there's the most values, and that it tapers off kind of to both sides. And when we're looking at a normal distribution, that's what we're looking for. If this was flat all the way across, that would be more like a uniform distribution where you might have any range, and you have equal probability of getting any of these values across the range of values that are available. We could also think about a skew where it might look like it kind of comes up like a ramp over to one side or to the other side. And in those cases, those are deviations from normality. And in that case, our t-test won't be telling us what we need it to tell us. There is one of these variables that deviates from normality in this example, but I just want you to kind of ignore that for now and understand what it is that we're looking for and why when we're doing normal distributions. So let's make one for Virginica as well. Again, start at the top, Control Shift down, insert, and we go to histogram. So now we can call this one Virginica. And we can see that this too kind of has this same range, this same kind of normal distribution where it puffs up at the top and tapers off to the sides. And so there are statistical ways that we can check this, but visually assessing normality in this way by just looking at a histogram is also reasonably valid. Statistically checking for normality in Excel is pretty difficult, so we're not going to be doing that for this introduction example. The next assumption that we want to test, I'll just write that actually above these two so that we can keep track of what we're doing here. So testing for assumptions of normality. Now what we want to do is test for assumptions of equal variances. When we're testing for that, so the t-test assumes that these there are different types of t-tests, and one of them assumes that the variances are equal, and one of them assumes that the variances are not equal. And basically, if the variances aren't equal, it's just more cautious in saying that there's something going on. So it's important that we understand which of these is actually what is going on with the variances relative to the two groups that we're comparing. So one thing that we can do is we can just look at our sample variances here. And you can see that the sample variance for Setosa is only 0.12, whereas the one for Virginica is 0.4. So Virginica is almost 3.5 times the variance of Setosa if you look at them relatively. And that kind of points to them not being equal. But since we're practicing, let's use a statistical test that's available in the data analysis toolpack to actually confirm this. And so what we're going to use is an f-test. And the f-test, similarly to the t-test that we're going to be using, has the null hypothesis, this h0, that there is no difference in variance between groups, meaning that they're the same. And we have our alternative hypothesis, which is that there is a difference in variance between groups. So now what we're going to do is go back to our data tab and to the data analysis, and we go to this ftest to sample for variances. We click OK, and it wants us to input our variable 1 and our variable 2 that we're comparing. So we start at Setosa, and we go Control-Shift down, highlight the whole thing. Then we go to Virginica, we click that, Control-Shift down, highlight the whole thing. We look at labels, and we choose where we want it to output. So we output just below this other grouping of text that I've written. Now we have this alpha parameter here, and so what this is our significance level. Now this is saying what is the level of confidence that you, or the level of significance that you want to determine for rejecting your null hypothesis. So we'll look at that when we come to the output, but this is kind of a standard, is this 0.05. So now we have this output here, and we can see that there's this P of F being less than or equal to F, one tail. And so the F's and the comparisons between the F that it calculates and the F critical are less important for our purposes than being able to interpret this p-value. And so our p-value here is 0.00003. It's really, really small. And in this case, our p-value is less than 0.05, which is that critical alpha value. And because our p-value is less than 0.005, it means that we can reject our null hypothesis. So again, our null hypothesis is that there's no difference in variance between groups. The p-value tells us the probability that our null hypothesis is true, and the probability that our null hypothesis is true is really, really, really low. It's much less than our threshold value, and so in this case, we can reject the null hypothesis, and we can accept the alternative. And so what we mean by that is that there is a difference in variance between groups. And so what that means is that we need to use a t-test assuming unequal variances. So t-tests are also really easy to do within Excel. So we click here, we go to our data analysis, and we go to t-test. And there's a couple of different options for t-tests: paired, to sample with equal variances, or to sample with unequal variances. And we just found that we have unequal variances, so we have to click that one. Again, it wants our variables, so we start at Setosa, Control-Shift down, then we pick Virginica, and we go Control-Shift down, and we tell it that we have labels in the first row. For the t-tests, it allows us to specify what our hypothesized mean difference is. This is our null hypothesis, and in this case, we're saying that our null hypothesis is 0. It allows us to pick where we want to output it, and we're going to output it here. Just a few rows below that one so I can write some stuff. So now what we're going to do is, I should have written this ahead of time, but we're testing for differences between means. And in this case, our null hypothesis is that there is no difference between means, and our alternative hypothesis is that there is a difference between means. And similarly to our f-test output, in this t-test one, we have these two different p's. And one of them is our one-tail p-value, which is looking at if there's a difference in one direction. And then we have our two-tail p-value, which looks at if there's a difference in two directions. And so both of these are p-values, but the two-tail one, you'll notice, is a higher number, which means that it's being more cautious in it. And so if you want to look in both directions, the test is just going to look, be a little bit more cautious in using that p-value. In this case, it's not going to affect our interpretation. And so again, our p-value is the probability that the null hypothesis is true. And in this case, there's 24 zeros before this 3, so it's infinitesimally small. Again, our p-value is less than 0.05, and so we are able to reject our null hypothesis that there is no difference, meaning that we accept the alternative, and we conclude that there is a difference between means. And so again, this p-value tells us the probability that the null hypothesis is true. So it's very unlikely that these are the same, but it doesn't tell us anything about how different these actually are. And so that's a different type of test that we would do. And so it's important to remember that the p-value is the probability that the null hypothesis is true. I think you should get this tattooed on your forearms. And so with that, we have our t-test. And so if we were to put this figure into a report, we could conclude that there's a statistically significant difference between the means of sepal length for Setosa and Virginica. And so what we're going to do is do that for all of the different variables that we have. Now, it's easy once you have this first definition query, the first power query that we did, to use it again for the other variables. So we can go to query, we can go to edit, and once we're in the power query screen, we can right click on sepal length and we can duplicate it. Now, let's go ahead and change the name so that we don't forget. And so instead of sepal length, we're going to do petal width. So we can go to where we selected the columns that we want to have, and you see this, even though we changed this name, it still has sepal length as the values that we're using. So we click this little gear to edit this step in the query, and we say instead of sepal length, we want to have petal width. And then we press OK. And you'll see that these values have changed and that the name of the column has changed. The problem is that where we grouped rows and we added the custom and we did all these other steps, it still thinks that this column is named sepal length through all these steps. So the easiest way to get around that is just between those steps. So after we removed the other columns, we just change this back to sepal.length, making sure that we have these capital letters and the period. So by adding that step, our query is going to say, do you want to add a step into this? It might break our query, but we know it's actually going to fix it. So we insert the step, and now we go to the end, and we actually have all of our values. So with that, you can close and load. And you'll see that we have a similar looking table, but it's for petal width instead of for sepal length. Now you can start to do the same thing with the descriptive statistics, the box plot, the f-test, the histograms, and then finally our t-test for these ones. Now, one thing to note is that we have determined in class that this variable deviates from our assumption of normality. In this case, it does not come up to this hump in the middle. It's kind of really sent like close to these 0 values, and then it kind of tapers off to this side. And so this is what we would call a right skewed distribution, and it deviates from normality. In this case, though, just for the example, I would like you to conduct the t-test on it anyway, although normally this would be grounds for you using a different statistical test. But for the sake of our assignment, just go ahead and do it like it meets the assumption. There's another way that you can do this, and so say your power query is giving you grief and you're just sick of trying with it. Another easy way that you can do this is just to highlight all the values that are for Setosa. So we stop here at the bottom of Setosa and we just press Control-C to copy. We are looking at petal length, so we make a new sheet and we call it petal length, and then we copy those values, and we want to make sure that we copy them into the second one so that we can say that this is Setosa, and then we can make another column beside it for Virginica. And we can do the same thing where we go to our raw data and we just highlight this all, Control Shift down, copy and paste. And then you see that we have a similar structure to these other ones. We don't really need this index by species. It was just for our Power Query, but this is the easier way to do it. And the reason that I have you doing Power Query is because it makes your work more replicable, and it makes it so that I can look at these queries and make sure that you are taking the right steps, as opposed to me having to say compare all these values to make sure that you got the right ones here. And it makes it so that anyone can go into your book and do just that. But for the assignment itself, I would like you to have this sheet with all of this information. You don't have to write out all the text stuff, but if it helps you, that's fine too. For your reports, you only have to take this figure, which looks something like this, and insert it into your reports with an appropriate caption, as well as an in-text cite or reference. And that is all that we're hoping to get at with this assignment, and I would like you to make sure that you're interpreting these correctly. So good luck with the rest of it.